All right, some people asked about an alternative strategy to the one I showed on the answer key. What if we took the volume and surface area formula and condensed those to one equations? So to do that, you would just use the substitution method. Solve for s, so in this case, s is equal to v to the 1/3 power. Substitute that into the other equation, so the surface area is 6 times v to the 1/3, or 6v to the 2/3. That would be one way of doing it. You might have solved for s here. S squared is a over 6, so s is the square root of a over 6. And then plug that expression in for s into the other equation, giving a single equation for volume. So one of the others could be your single one equation. That was redundant. All right, so we need the derivative with respect to t. So dv dt here, which is 2, is equal to the derivative with respect to time of the right side, which is 3/2 times a over 6 to the 1/2, times the derivative of the inside, which is 1/6 dA dt. Now, if we multiply both sides times 6, this 2 becomes 12, and we need a value for the surface area. Well, if the side is 5, then the surface area is 150. So 150 over 6 is 25. 25 to the 1/2 power is 5. We have 15 halves. So to find what they asked for, how fast is the surface area changing, we'd multiply both sides times 2/15, which gives us 24/15, or 8/5. If you had gone this way and condensed this to one equation, and then take the derivative with respect to t, dA dt, which is exactly what they're asking for, how fast is the surface area changing, that's going to be 2/3 times 6, which is 4, times v to the negative 1/3, times the derivative of v with respect to t. And we know that this is 2 at that moment when the side is 5, and if the side is 5, then the volume is 5 cubed, or 125. So 125 to the negative 1/3 is 125 to the 1/3 in the bottom, which is 5. So we get 4 over 5 times 2, which is also 8/5. So this was another way of doing the problem, in case anybody tried it that way.